Welcome to the course Business Analytics and Data Mining Modeling using R Part 2. So, as we talked about in the previous lecture, the first lecture, that this is a continuation of a previous course on Business Analytics and Data Mining Modeling using R. So, in the previous lecture, we started our discussion on association rules. So, let us continue that. So, we talked about the basic idea of association rules and what we try to achieve using this particular technique. So, that part was discussed in the previous lecture. We talked about the market basket databases. We talked about how this particular technique can be applied in for various business challenges, analytics challenges. So, all that discussion was done. We talked about association rules and the if then statements that are used to formulate these rules, to express these rules. We talked about the two-stage process that is used in association rules. First one, rule generation, second one, assessment of rule strength. We also started our discussion on rule generation part of it, and few things that we were able to discuss. We used this particular example, mobile phone cover purchase, and we talked about candidate rules generation. Few things we were able to discuss. We talked about antecedent and consequent item sets. Then we discussed few things about rule generation, and we talked about the problems that are associated with these steps, and then we talked about the importance of frequent item set and how it could be used for next steps. So, then we talked about the concept of support, which is again associated with, which is actually required for us to create this frequent item set. Then we ended our discussion at this point, and so let us carry forward this discussion. So, next thing that we are going to discuss is Apriori algorithm. So, this is the classic algorithm given by Agrawal, which is typically used for association rules. So, we are talking about the rule generation process, rule generation stage of this association rules process. So, a priori algorithm, if we look at the overall major steps, then the first step is going to be generate frequent item sets with one item sets. Then recursively generate frequent item sets with two item sets. Then we move to the same thing with 3 items and so on for all sizes. So, this process is to be done for item sets with all sizes. So, now let us look at the first step in a bit more detail. So, generate frequent item sets with one item sets. So, it is easier to identify the item sets, one item having just one item. So, once we are able to list all those item sets which are having just the single item, then we can compute support for these one item sets. So, support, how do we compute that, we have already talked about. Let us revisit it again. So, we talked about the support of a rule being a number of transactions with both antecedent and consequent item sets. So, in this fashion we can compute the support value for all the item sets which are having just the single item. Now, as we talked about that user has to specify a minimum support level that is required for us to select a to consider a item set as a frequent item set. So, we need to drop then sets having support below that user specified minimum support. Once that is done, the remaining sets can be called as frequent one item sets. So, it is the user specified minimum support level which gives us the criteria for deciding whether a one item set is going to be considered as frequent one item set or not. So, once this process is completed, then we will end up with the frequent item sets with the just one item. So, this process as we talked about, the second step is again in the second step where 2 items are involved. So, we are dealing with item sets having 2 items. So, here in this case we start with what we have already created. So, we have already created frequent item sets with 1 item. So, we start with that list and use that while generating frequent item sets with 2 items. So, as you can see in the first sub step in this is use frequent 1 item sets to generate 2 item sets. So, why this is done? So, as it is noted here, since larger size item sets containing non-frequent 1 item sets will also be non-frequent item sets. So, if if we have a non-frequent item set having just a single item and it is included it is used to create an item set with 2 items, then of course it is also going to be the non-frequent. So, therefore, if we just work on the list of frequent 1 item sets, then that would actually lead us to frequent 2 item sets. So, this is why we start with frequent 1 item sets. Now, once we have listed all the all these 2 item sets, then we can compute support for them. So, these 2 item sets, as I talked about, have to be generated using the frequent 1 item sets. So, once these 2 item sets are there, then we can compute support for them and then drop the sets having support below user specified minimum support. So, once that is done, the remaining sets they would be the frequent 2 item sets. So, if you look at the process, it is easy to understand what we are going to do in the next step. So, to review these 2 steps again. So, first we start with in the first step we try to create frequent item sets having just single item. So, these are 1 item sets. So, easier to identify these 1 item sets, then we compute support, then we drop those 1 item sets which are having support less than user specified minimum level, and then the remaining sets are used for the next step. Now, in the next step the item sets with 2 items we only consider 2 item sets which are based on frequent 1 item sets. So, once again we compute support and then drop the ones to drop the ones having support below minimum user specified minimum level, and then the remaining set would serve as frequent 2 item set. The same process is repeated with 3 items and item sets with 3 items and more. So, if we look at the main idea here is we typically generate k item sets using frequent k minus 1 item sets. So, this actually allows our algorithm to be computationally cheaper, in the sense the algorithm a priori algorithm is quite fast because we have to go through just one pass through the database. So, as you can see this point is noted here. So, a priori algorithm is quite fast even for a large number of unique items. So, each step requires a single run through the database. So, now to again look back at this a priori algorithm. So, we are trying to first we try to create item sets, frequent item sets with 1 item, then use this list to create frequent item sets with 2 items, then use this list to create frequent item sets with 3 items, and then so on. So, in this process in this fashion we are able to reduce the number of computational steps, and the algorithm is quite fast. So, this is the a priori algorithm that is used for rule generation. So, let us move forward. So, next stage of the process is assessing rule strength. So, how do we compute rule strength? Now, we look at the main idea. So, as you can see, the main idea is to identify rules which capture a strong association between antecedent and consequent item sets. So, that is the main idea. So, we are interested in finding or capturing the a strong association between these two item sets, antecedent and consequent item sets, because as we have talked about, our rules go like this, that if x has been purchased, then y is also going to be purchased. So, if you see that there has to be some sort of association between item set x and item set y. So, therefore, our assessment of rule strength should be able to capture this strength. So, metrics that can be used to measure this measure strength of this association as implied by a rule. So, first one is confidence. So, what we mean by this matrix? So, confidence is ratio of number of transactions with antecedent and consequent item sets to the number of transactions with the antecedent item set. So, if we really look at this formula, so from the group of within the transaction which are having antecedent item set, we are looking to find out the proportion of these transactions which are also having the consequent item sets. So, we focus on the transactions which are having the antecedent item set, and then we try to compute the proportion which are also having the consequent item set. So, that this value gives us the confidence number. So, as you can see that through confidence, if for a given rule, if the confidence is higher, then probably the strength of the association between antecedent and consequent is also on the higher side, because if the confidence value is higher, then the appearance of or co-occurrence of antecedent and consequent item set is on the higher side. That means, whenever there are more chances that whenever antecedent item set is present, the consequent item set is also going to be present. So, you can see if the confidence value is higher, then the strength of this association is also going to be on the higher side. So, this is one metric that is used. Then another metric is lift ratio. So, lift ratio is typically, as we have covered in the previous course, typically we compare it with average case or benchmark scenario case, and then see how much the lift is being provided by the model. So, in this particular technique also it has the same sense, same meaning. So, we will discuss this in later in this particular lecture. Now, at this point, let us revisit the two important metrics that we have talked about, support and confidence. So, if we support can also be thought of as probability of antecedent and consequent items, occurrence of antecedent and consequent items among the transactions in the database. So, we can also think about support as this probability value. Similarly, if we look at the confidence, so confidence can also be thought of as probability of antecedent and consequent item sets divided by probability of antecedent item sets. So, in this we can also think about these metrics, support and confidence, in probability terms. If we look at the confidence, once we think about confidence in terms of probability, we can see that confidence can also be rewritten as the conditional probability, where we are trying to compute the probability of probability of antecedent given the consequent. So, typically high value of confidence, as we talked about, high value of confidence means strong association rules. So, however, this might not be true in all the cases, because in some cases where antecedent or consequent item sets have high support, it might lead to high confidence despite no real association. For example, if you have some transactions where the customers, almost all the transactions involve tea, and almost all the transactions involve some snack, some snack. So, both these items will have high support and therefore will also end up having high confidence value. So, there might be cases where particular antecedent item set and consequent item set, they have high support, and that might be leading to high confidence despite there is despite no clear association between the items. So, typically we can rely on this high value of confidence, meaning a strong association. However, there might be cases where this might not be true. Now, let us talk about the next metric. So, this is lift ratio. So, as we talked about, we try to, as we have discussed in previous course as well, that typically we compare with the benchmark scenario or average case scenario. So, here also lift ratio compares the confidence of a rule with its benchmark value. Now, what do we mean by benchmark value in this case? So, you can see the next point is the benchmark value of a rule is confidence value computed by assuming no association between antecedent and consequent item sets. So, when we assume this, then we compute the confidence value, and this confidence value is treated as a benchmark value, and then we compare it with the confidence of the rule, and we get the ratio. So, let us look at this particular process in more detail. So, we assume that antecedent and consequent item sets occur independently. This assumption is to compute the benchmark value. So, if this assumption is there, then the probability of antecedent and consequent item sets occurring can also be rewritten as probability of antecedent multiplied by probability of consequent. So, if this is true, then we can plug this particular expression in this confidence formula, and we can compute the confidence in the benchmark case. So, you would see that in the numerator part of it, we will have the probability of antecedent multiplied by probability of consequent, and then this whole expression is divided by probability of antecedent. So, in the end we will get the probability of antecedent. So, you would see that confidence, the benchmark value of confidence is nothing but the probability of antecedent happening. Now, this benchmark confidence we can rewrite as number of transactions with consequent item set divided by total number of transactions. Let us revisit the concept of support and confidence, the two metrics that we talked about in probability terms. So, support can also be thought of as probability of occurrence of antecedent and consequent item sets. Similarly, confidence can also be thought of as probability of occurrence of antecedent and consequent item sets in the numerator divided by probability of antecedent item set. So, this can also be rewritten as the probability of conditional probability of consequent given the antecedent item set. So, in this fashion we can rethink these two metrics, support and confidence, in probability terms. And so, we can think about that probability of in all the transactions that we have in the database. Support can be thought of as the occurrence of item sets belonging to antecedent and consequent in the whole database among all the transactions. Similarly, confidence can be thought of as probability of occurrence of antecedent and consequent item sets among the antecedent item sets. So, we can always think about these metrics as support and confidence. Now, as we talked about that typically high value of confidence means a strong association, but sometimes it might not be true. So, sometimes the antecedent or consequent item sets, they might have higher support, and which might lead to higher value for confidence. So, even though there is no real association. For example, if there are two items that are being purchased by most of the customers from a cafe, and those two items do not have any association, but because these two items are frequently purchased by most of the customers, so they will have high support, and therefore, the confidence value will also be on the higher side. So, there are some situations where the typically high value of confidence might not mean the strong association. The next metric that we are going to discuss is lift ratio. So, as we talked about in the previous course also, lift ratio has been used in many techniques, where we always try to compare the performance of the model with the benchmark case or the average scenario case. So, similarly here also lift ratio is about comparison of confidence of a rule with its benchmark value. Now, what do we mean by benchmark value in this case? So, as you can see in this in the point that is mentioned in this particular slide, the benchmark value of a rule is a confidence value computed by assuming no association between antecedent and consequent item sets. So, here to compute the benchmark value, we are assuming that antecedent and consequent item sets, they occur independently. So, what this means is that the probability of occurrence of antecedent and consequent item sets can also be rewritten as the probability of antecedent item set occurring multiplied by probability of occurrence of consequent item sets. This is just like the independent events probability. When two events are considered to be independent, their probability can be computed as the we can multiply the probability of individual events occurring, right. So, in this fashion the benchmark confidence value can be rewritten. You can see the numerator part here, the numerator changes to p probability of antecedent multiplied by probability of consequent and divided by probability of antecedent. So, you can see that it will result into the probability of consequent. So, you can see that the benchmark confidence value essentially becomes the probability of occurrence of consequent item sets. So, we can also rewrite this particular expression benchmark confidence as in the numerator number of transactions with consequent item set divided by total number of transactions. So, in this fashion we can use this particular formula and compute the benchmark confidence value, and then it could be used later on to compute the lift ratio. So, how do we define lift ratios? As you can see here, lift ratio can be computed using this formula. So, in the numerator we have the confidence, and it is going to be divided by the benchmark confidence value. How do we compute benchmark confidence? We have already discussed confidence formula, we already understand. So, in this fashion lift ratio we can compute. Now, how this lift ratio can be used to find out the usefulness of a rule. So, as you can see here, if the lift ratio is greater than 1, that means the confidence of a rule is greater than its a value, the value of benchmark case, value of benchmark scenario, where we assume that there is no association between antecedent and consequent item set. So, lift ratio value of greater than 1 means that in comparison to the scenario where antecedent and consequent item sets are assumed to be independent, the confidence value is higher than that. So, typically larger the value, larger the lift ratio value, greater the strength of the association. However, lift ratio is able to overcome that problem that we talked about, the problem related to confidence formula, where the high value of confidence typically means the stronger association or a stronger association between those sets, antecedent and consequent item sets, and we talked about that in some scenarios it might not be true. We had given the example of two snacks being purchased from a cafe. So, that problem can be overcome using the lift ratio metric, where we are comparing with the benchmark confidence. So, this seems to be a much better metric in terms of judging the strength of association rules. Now, let us discuss the transaction data formats. So, there are two popular data formats that are available to store the transaction data, transactions of a database. So, first one is called item list format. So, then in this item list format, each row contains a list of purchased items and represents a transaction. So, all the rows represent a particular transaction, and each row will contain list of the items, they are essentially item names. So, this is called the item list format. The second format is binary matrix format. In this particular format, rows represent transactions. So, again rows are still representing transaction, but the column represents items. So, now when the column represents items and rows are representing transactions, the cells can have either 1 or 0 value that would indicate the presence or absence of that particular item in the transactions. So, for a typical any column, a particular column would represent a particular item, and if the value for that cell in a particular row in a particular transaction is 1, it will mean the presence of it. Otherwise, if the value is 0, then it will mean the absence of it. So, this is the binary matrix format. So, these are the two formats that are typically popular and used in the association rules mining and the related discussion. So, let us in the previous lecture we had talked about the mobile phone cover example. So, let us go back to that example. Let us open RStudio and let us discuss these two formats. So, let us revisit this example. So, here as we can see that the example purchase of mobile phone covers. We talked about this particular example, we have 10 transactions here. So, you can see the first item list format here. So, you can see the item list format here, and you can also see the 10 transactions that we talked about in the previous lecture as well. So, this is essentially the item list format. You can see right now we have created it using a list in R, and this can be executed. Let us run this. Now, you can see from here that you can see this list has been created. You can see each row is representing a transaction, and the item names are given red, white, green for the first transaction, for the second transaction white, orange, the third transaction white, blue. So, in this fashion for all of these transactions, total 10 transactions, we can see the item names are given. So, in this case item names are being represented by the colors, because as we talked about, this particular example is about if a customer is purchasing mobile phone cover, which colors they are more likely to purchase together, right. So, in a particular transaction we can see the covers with different colors that are being purchased in a single transaction. So, this is the item list format. To look at the binary matrix format, we will have to use this particular package, library A rules. So, let us load this particular package. So, right now this package is not installed in the system. So, let us install this. So, the command that we are going to use is the install dot packages, and we will use the package name in double quotes, A rules, and then so this package is being installed. So, A rules, this is the most popular package that is available available for our environment. So, this is used for association rules modeling. So, once this is installed and loaded, we will be able to create this binary matrix format for our data set, this mobile phone purchase data set. Now, the installation is almost complete. Now, let us load this. So, we will go back to our code. Let us run this. You can see the package has been loaded now. So, now as we talked about, the class item matrix is part of this particular package, and this can be used to store a binary incidence matrix, item labels, and optionally transaction IDs and user IDs. So, this particular class that is part of this package A rules can be used to store data in various formats. So, right now we are interested in creating the binary incidence matrix. So let us run this. So as you can see, this list that we have already created, it has all the 10 transactions in the list format. Now we are going to use this as function, which is going to coerce this list into the transactions format. So let us run this. Now inspect is the function that can be used to actually look at this particular format. So more detail about the inspect function you can find out from the help section. So here again you can type in the help section inspect, and you would be able to find more detail about this particular function. So as you can see, provides the generic function inspects for to display association and transactions plus additional information formatted for online inspection. So this is the function that we are going to use here. So let us run this particular code, and you can see here all the transactions listed in these braces. So items, you can see first transaction green, red, white, second one orange, white. So all these are being shown in curly braces. So each row is representing a transaction and the name of item. So this is essentially the item list format. So now we can also display the same information in image format. So the function that we are going to use is image. So let us run this. So you can see in the plot section, we have on the row side we have items. So as we talked about in the previous lecture, in this particular database we have just 6 distinct items. So you can see 6 columns here, and each row is representing a transaction. So these colors are indicating the presence or absence of that particular item in that transaction. So you can see here that, for example, transaction number 1, we have item 2, item 4 and 5 present, right. So in this fashion we can have a visual representation of this particular database, this particular transaction database as well. Then we can use summary function as well to find out a bit more detail about this. Now this particular, once this we have this transaction format with us, we can create a matrix format. So you can see as function is being used, and now the format is matrix. As you can see in the second argument, matrix is being passed over here. So let us run this, and we will get the matrix format. Now let us look at the output. As you can see that the column names are being represented by the colors, different colors for the covers, mobile covers. You can see blue, green, orange, red, white, yellow. Here you would also notice that these colors are right now these item names are arranged in the alphabetical order. You can see blue comes first, then green and orange. So they are arranged in alphabetical order. However, you might want a different order, so that can also be done. So for this we will have to create this labels for these items. So you can see the next line of code. You can see this is the order that we want, first red, then white, then blue, orange, which is not necessarily the we might not want the alphabetical order sometimes. So in this fashion we will have to create the labels, and then we can use encode function to change the names of column labels, right. So in this fashion we can move forward. So let us run this, and then encode function can be used to change these label names, and you would see we have run the inspect of this new variable, and you can see this is right now, this is, you can run the image function. You can see here, now we can create our new matrix. Now if we scroll, you can see the column names, the order has changed. Now depending on the order that you want, you can create in this fashion, and this is the binary matrix format that we have. So two matrix format, item list format and binary matrix format, that we have been able to cover. So we will stop here and we will continue our discussion in the next lecture. Thank you.